Today's video lesson is on areas of trapezoids, rhombuses, and kites. Objective by the end of this lesson is you should be able to find the area of a trapezoid, rhombus, or kite. The height of a trapezoid is the perpendicular distance between the bases. Therefore, we have area of a trapezoid will be half the height times the sum of its bases. So half times the height times the sum of the bases, where the height is the perpendicular distance between the bases. So we have Nevada is shaped somewhat like a trapezoid. So I can find the area of Nevada by using the trapezoid formula. So here's B1, here's B2, and here is H, 309. So if the area of a trapezoid is half the height times the sum of the bases, I know that the height is 309. Sum of the bases, it doesn't matter which one you label B1 or B2. I usually label the shortest base B1 and the longer base B2. 205 plus 511. Remember, it's adding the bases, not multiplying them. So I have area equals half of 309 times, we have now 205 plus 511, 716. Okay, then when we multiply everything out, we have a half times 309 times 716. So area of Nevada is about 110,622 square miles. Let's do a second example. So I was the area of a trapezoid with height 7 and bases 12 and 15. Well, I will draw a trapezoid. So here's my trapezoid. I have height 12, or sorry, base 12 and 15, and I have a height of 7. Well, here's my height. So remember, the height is the perpendicular distance between the bases. So here is 7. So area equals half times the height times the sum of my bases. So substitute the numbers in. Again, 12 is B1, 15 is B2, 7 is the height, and I have 15 plus 12. So area equals half of 7 times 15 plus 12 is going to be 27. So I have a half times 7 times 27 gives us 94.5. So area is 94.5 square centimeters. Now we can find the area of a trapezoid, but I'm missing the height. So I'm going to have to think back to my triangle rules, and more precisely my special right triangle rules, or you can use trigonometry. So notice that I don't have a height. Well, I can find my height. So I'm going to draw one in. So there's my height. I'm missing it. I have B1 and I have B2. So area equals half of H times 5 plus 7. So I'm missing the H. I don't know the area. But you should notice, okay, that triangle PS, I'll do M. So PSM is a right triangle. If I know the whole distance is 7, I know that. So if I know P to Q is 7, and I know that S to R is 5, therefore M to Q is 5, therefore P to M will be 2. So this segment is 2. So if I have a right triangle, a special right triangle, here's H, This is 2, 60, S, M. This is 30. So here's your special right triangle, 30, 60, 90. So here's your short, here's your long, and here's the hypotenuse. So you should remember your rules that short times radical 3 will give me the long. So the height is going to be 2 square root 3. So 2 square root 3 is my height. How did I get that? By creating a right triangle and using my 30, 60, 90 rules. So now I have my height. So I can finish up the area formula. So area equals half of 2 radical 3, 5 plus 7. So it's half 2 radical 3, 5 plus 7 is 12. So I have half times 2 radical 3 times 12, which gives us 12 radical 3, which is equal to 12 radical 3, which is about 20.8, which is about 20.8 meters squared. So if you're missing a height in a trapezoid, you're going to have to create a right triangle. If you create a right triangle, you're going to have to think back to your right triangle rules. To solve for a missing side in a right triangle, you might have to use Pythagorean theorem, you might have to use sine, cos, or tan, or you could use your special right triangle rules. So a lot of prior knowledge is required. What's the area of the trapezoid? So I'll put in that this is a right trapezoid. I don't have a height, so I'm going to draw one in. Notice that I always draw in my height so that I create a right triangle. I'll label A, B, C, D, E. Well, C to B is 4, therefore D to E is also 4, but if the whole thing is 10, from D to A is 10, therefore E to A has to be 6. So I don't have my height, I have base 1, I have base 2, since I'm missing my height. Hint, create a right triangle by drawing in your height. So I have a right triangle. Here's A, B, E, here's H. This is 6, this is 45, therefore this is 45. So it's a 45, 45, 90, therefore the legs are congruent, so H is also 6. Because legs in a 45, 45, 90 right triangle are congruent. So now I have everything. Okay, B1 is 4, B2 is 10, and H is 6. So area equals half of 6 times the sum of 4 and 10. So half of 6 times 14. So I have half of 6 times 14 gives me 42 units squared is my area of this right trapezoid. So here's a more difficult problem. What's the area of the trapezoid? I give you a height, I give you base 1, I don't give you base 2, so you're going to have to solve for base 2. Well, here is Q, and here is R. Well, if B to C is 8.4, therefore Q to R also is 8.4. So I need to solve for Y, and I need to solve for X, because I need the entire base 2. So here's base 1, here's my height, and again from A to D is base 2. I don't have the whole base 2, I have part of it, which is 8.4. Well, I have a right triangle on the left hand side. So here's A, 50, 90, B, and Q. I know this is 5.7 and this is Y. Well, to solve for Y, it's not a special right triangle because it's not 45, 45, 90, or 30, 60, 90. To solve for Y, I can't use Pythagorean theorem because I don't have the hypotenuse. So I'm going to have to use sine, cos, and tan. So my reference angle is 50. So the side given opposite of 50 is the opposite. Y is adjacent to 50. Therefore, the trig ratio that is opposite or adjacent is tan. So to solve for Y, I have the tan of 50 equals 5.7 over Y. Solving for Y, cross multiply, then divide. I have Y equals 5.7 over tan of 50. So Y is about, so we have 5.7 divided by the tan of 50, which is about 4.8. So Y is about 4.8. So this is a 4.8. I now repeat the process for CRD triangle. So I have a right triangle. Here's CRD. This is 31. This is also 5.7 because the heights in a trapezoid can never be different. And I want X. So I have opposite given the angle, and I have adjacent to the given angle. Therefore, it's tangent. So I have the tan of 31 equals 5.7 over X. Cross multiply and divide. I have X equals 5.7 over tan 31. So 5.7 divided by the tan of 31 gives me 9.5. So X is about 9.5. So now base 2 is equal to 4.8 plus 8.4 plus 9.5. So I have 4.8 plus 8.4 plus 9.5. And I have 22.7. So B2 is 22.7. So all that work just to get B2. Now I can find the area of my trapezoid. So area is half the height. The height is 5.7 times the sum of my bases. So I have 8.4 plus 22.7. So half times 5.7 times the sum of my bases, which is 8.4 plus 22.7. And my area is 88.635 units squared. So with area of a trapezoid, it's not just plugging the numbers into the formula. You might have to do some trigonometry, Pythagorean theorem, special right triangles to solve for either the height or base 1 or base 2. Let's move on to area of a rhombus or a kite. It's the same formula. So the area of a rhombus or a kite is half times the diagonal 1 times diagonal 2. So multiply the diagonals and divide by 2 gives you the area for a rhombus or a kite. So find the area of a kite. D1 times D2 divided by 2. So D1 I'm going to call Ln, which is 3 plus 3. D2, diagonal 2, I'll call K to M, which is 2 plus 5. So area equals half of diagonal 1, which is 6, times 7. So half times 6 times 7 gives us 21 meters squared. So area of a kite or rhombus is half times diagonal 1 times diagonal 2. Area of a kite with diagonals 12 and 9 So D1 is 12, diagonal 2 is 9, area is half of D1 times D2, so area is half of 12 times 9. So half times 12 times 9 is 54. So area is 54 inches squared. So rhombus has sides 10 centimeters long. If the longer diagonal is 16 centimeters, what is the area of the rhombus? Well, let's draw in a rhombus. So here's my rhombus. So I have a rhombus has sides 10 and the longer diagonal is 16. So let's draw in my diagonals. You should know that the intersection of diagonals in a rhombus is perpendicular. So sides 10, 10, 10, 10, because in a rhombus all sides are equal. The longer diagonal is 16. So I'll have A, B, C, D. So I'll call D1 A to C, which is 16. So I need to find D2. Well, if A to C is 16, you should also remember your properties of a rhombus, which means that the diagonals bisect each other. So I know the diagonals bisect each other, therefore if AC is 16, therefore A to E will be 8. So I know this is 8 and this is 8. So I need to find X. Well, BEC creates a right triangle. So I have BCE, which is a right triangle. I have two given sides and missing a side in a right triangle, therefore I can use Pythagorean theorem to solve for x. So you should know that 10 is your hypotenuse because it's opposite the 90 degrees. So I have x squared plus 8 squared equals 10 squared. So x squared plus 64 equals 100. X squared equals 36, therefore x is equal to 6. X is equal to 6, therefore diagonal 2 is equal to 12. Because if x is equal to 6, B to D is 6 plus 6, which is 12. Okay, that was the length of B to D. So now I know my area, which is half of D1 times D2. Area is half of D1, which is 16, times 12. So half of 16 times 12 gives me 96 centimeters squared. So area is equal to 96 centimeters squared. So you can use Pythagorean theorem or trigonometry or special right triangles to solve for a missing part of a diagonal. So ABCD is a rhombus. Find the area, and I only give you that it's a rhombus. So if in a rhombus, diagonals will be perpendicular and bisect each other. So I'm going to create my tick marks, and all sides are 10. Now, you don't use the side lengths to find the area. You're going to use the side lengths in a rhombus to find the parts of the diagonal. So you should notice here in triangle ABE, you have a right triangle. So I'm going to redraw triangle ABE. I need x and I need y. Well, how do I solve for x and y knowing that I have 10 and 40 degrees for angle B? Well, I can't use Pythagorean theorem because I don't have another side length. I can't use special right triangles because it's not 45, 45, 90 or 30, 60, 90. Therefore, to solve for a missing side given a right triangle with one angle and one side, I use trig. So I'm going to solve for x first. So how does x relate to the angle? It's adjacent. How does 10 relate to the angle? It is the hypotenuse. Adjacent hypotenuse is the cosine. So the cosine of 40 is equal to x over 10. Cross multiply. So x is equal to 10 cosine 40. So x is equal to 10 cosine 40, which is about 7.7. So x is 7.7. Therefore, d to b is equal to 7.7 plus 7.7. So I have 7.7 plus 7.7 gives us 15.4. So there's D1. Now to solve for D2, I need to solve for y. So how does y relate to the angle? Well, that's opposite. And again, this is still the hypotenuse. 10 is still the hypotenuse. So opposite hypotenuse is the sine. So the sine of 40 equals y over 10. Therefore, cross multiply, you have y is equal to 10 sine 40. So go to your calculator, do 10 times sine 40, round to the nearest tenth, and you get 6.2. So if y is 6.2, and therefore that's 6.2, so a to c is 6.2 plus 6.2, which is 12.4, which is D2. Now the area is equal to half 15.4 times 12.4. So half times 15.4 times 12.4 will give us 95.48 units squared. So that's my area. And that concludes area of a trapezoid using trigonometry, area of a kite or rhombus using trigonometry or Pythagorean theorem or special right triangles. If you have any questions, please ask during class or send me an email.